Hmm. Tutorial. A triplet is considered good only if and sum of the digits of the sum is 4. A triplet is considered good only if each digit of the number n was obtained without carrying over during addition. For example, consider a equals to 7 and 4. Then the sum of digits is 13 and the sum of digits of the sum is 4. This means that whenever there is a carry of 1 in the digits, the sum is always increased. The sum is always more than the sum of that number. This allows us to consider each digit separately and multiply the answer. The answer for each digit x will be number of digits with the sum fx. These values do not depend on the input data, so they can be pre-calculated, but this is not necessary to pass the test. This is the condition that a triplet is valid. Uh, let's see, adding the low position 4 plus 3 plus 1. There is no carry. This is a good pair. But if there was a carry, then it would be a bad pair. I did not get the entire idea. But let's at least score what I got. Hmm? Why is it not loading? VS Code. Be my friend. CP. And that is C in T. Y T minus minus. LL and C in N. Now while N percentage by 10. While n is not equals to 0, LLD D is equals to n percentage by 10, n divided equals 10 for LLI equals to 0, I is less than ni plus plus for LLJ equals to j is less than nj plus plus. It's be from 0 to d plus 1. From j equals to 0 to j equals to d if d minus I minus j greater than 0. Let's make LL count equals to 0, count plus plus. Oh, LL mul equals 0 and mul plus plus. And this mul count should be above. Count multiply equals to mul. And finally, we have count and L. All the test cases have been passed. I did not ask for anything modular. This thing is just to find the triplets for all the numbers from 0 to 9. Nothing more. If D is 5, then 500 is a valid. 410 is a valid. 412 is as well a valid. It's like that. Okay. But still, this scary thing part is quite complicated. So let's just keep this for the future. Submit code. Submit. Surely it will get accepted. That won't be a problem. Now going to contest. Deuteria is solved 5 out of 7. Let's start from here. Yeah, I won't be doing any questions of graphs or trees. I can solve this. What's the question? Question love string. Someone has a string S, while Daniel has a string T. Both strings only contain 0 and 1. A string A of length k is good if and only if AI is not equals to AI plus 1 for all I. For example, 1101 are good while these are not good. He wants to make S good. To do this, he can do the following operations any number of times. Insert T to any position of S. Insert T to any position of S, getting a new S. Please tell him if it is possible to make S good. Number of test cases, two integers n and m, the length of the two strings. The second line of each test case contains a string s of length n and the other a string t of length m. The both strings are guaranteed to contain only 0 and 1. Print yes if it is possible and print no if it is not. Hmm. The second test case 111010. This is string s, this is string t. I want to make string as a good string. As I want to make it good, t I have with me. So first I have to check if S is good. S is already good. Yes. Else, if T is not good, no. Else, if T is good, see the first and last elements of T. If either of them is equal to the points in string S where we have a problem, then no, else yes. Uh, so I can just write the code and get it done with, oh, I don't know, LLT C in T while D minus minus LLN comma and C and M string S string T, no, not T. I guess it's okay. Just make this capital T, C in S and T. For I equals to 0, I less than n, I plus plus. If S of I is equals to S of I plus 1 and I plus 1 is less than and leg equals to leg 1 equals to 1. LL flag 1 equals to 0. And max, no, LL A of 2 is equals to LL A of 2. A of 0 is equals to minus 1. A of 1 is equals to minus 1. P of s of I minus 0 equals to 1. If like if f1, if not f1, see out here and L. Saying the same thing, but for t. If t of I is equals to 3 of I plus 1, see out no and L. As if t is good. If a of 0 is not equals to minus 1 and L reflect 2. If either t of 0 is equals to 0 or t of 1 t of m minus 1 is equals to 0, f2 equals 1 if the same thing for t of 1. But yeah, with the if a of 1 is not equals to minus 1. Now, if f2 see out no and else see out yes and hmm, if f1 is lesser than or equals to 0, break. If yes, else, if entire is in a big else, and then f3 is equals to 0, f3 equals 1. F3 equals 0. F3 equals 0. F3 equals 1. If F3, C out, yes, and L, C out, no, and L. This big if, what if? This is for the while. Okay, this comes here, it closes here. F3 equals 1. L, F3 equals 0, break. If F3, F4 equals 0, F4 equals 1. If not F4, only then to this entire thing. If A of 0 is not equals to minus 1, then if A of 1 is not equals to minus 1, then this. If F2 else uh, uh, how does this work now? Yes, yes. No, no, no. Control C. Try again. Expect yes. Yeah, F3 and huh? C out H and L. Huh? They are not equal, so it's good. All is good. A of 0 is not equals to minus 1. See out A of 0 and A of 1. A of 1 is 1. If T of 0, huh? Huh? Yes, yes, no, no, no. Okay. Submit B running on test 1. Wrong answer on test 2. Huh. 190th token. And this were out of 2000 test cases. What to do? I don't like to. I don't like to play with my brains for this thing. But I'm pretty sure this is the answer. What if no? Just show me the answer at this point. And there is no substring one. Huh, I read the same thing. It's just wait a second. If two codes the same and they are rewrite this code yes, yes, no, no, no. Submit, submit. 193 token. Hmm. Hmm. Um, okay. Both like true and F1 and F2. F1 equals and F2 equals if T of I is equals to T of I plus 1. Hmm. Let us try writing a different thing. I'm not so sure, but let's see. Control C, Control V. If T of I is equals to T of I plus 1, F of 2 equals 0. If F1 hmm, if not F1 and not F2, they are no and else if F1 not F1 the out and L huh, LLF3 equals 1 for LLI equals to 0 I is less than and I plus plus if S of I is equals to S of I plus 1 if S of I is equals to S of I plus 1 if S of I is equals to T of 0 or S of I is equals to T of 1 and minus 1 F3 equals to 0 break if F3 C out yes and L C out no and L hmm. uh, Huh? 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 Now submitting the code and why? 198 token once again. What is this? This is 5 equals to S of I plus 1. 1. This could cause a problem. Oh, this was the cause of the problem. Minus 1. Huh. Uh, this is the new code, and this is the one wrong code. I want to submit that as well. Dun, 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 dun. And if you accept it, I don't care. So what's the third question? Low strings a little too much. And let's see the tags of this of variable. Has a string S which contains only 0 and 1. A string A of length k is good if and only if A of I is not equals to A of k minus I plus 1. For all I is equals to 1 to k. This condition is different from the condition in problem B. Why it's different? For example, 10, 10, 10, triple 1, triple 0 are good, while they are not good. One second, A of I is not equal to A of k minus I plus 1. Wants to make S good. To do this, she can do the following operation at most 300 times. Insert 0, 1 to any position of S. Please tell her if is it possible to make S good. If it is possible, print a sequence of operations that makes S good. So we even have to print them. For each test case, if it is impossible to make S good, output -1. Otherwise, output P, the number of operations in the first line. Then output P integers in the second line. The ith integer should be an index xi. the position where you want to insert 0, 1 in the current S. If x of y is equals to 0, you insert 0, 1 at the beginning. Otherwise, you insert 0, 1 immediately after the exact character of S. We can show that under the constraint in this problem if the answer exists, there is always an answer that requires at most 300 operations. Oh, so I don't have to care about the 300 thing. A of I is not equals to A of k minus I plus 1. A string A of length k is good. So the length of string 111000 is 6. So k is equals to 6. 6 minus I plus 1. So A of 0 should not be equals to A of 6 minus 0 plus 1. Uh, I from 1. A of 1 should not be equals to A of 6 minus 1 plus 1. A of 1 should not be equals to A of 6. A of 2 should not be equals to A of 5. Oh, so wouldn't that guarantee that odd number of string will always... No. Currently, the odd number of length of the string will be not good. But I can't talk about the future. So let's see in what test case. Last second, last third. Uh, 0, not possible. Also 1, 2, 3, 4. 0, 0, 1, 1, 1, 0. Again 0, 0, 1, 1, 1, 0. These two are equal, which is bad. So I will add a 0, 1 to the right side. 1, 1, 1, 0, 0, 1. These two are not equal, but these two are equal. So I will again add a 0, 1 to the right side. 0, 1, 1. Okay. Not equal, not equal, not equal, not equal. Wait a second. 1, 1, 1. 0, 0, 0, 1, 1. Good, 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 and good. So it took two operation, which is the same in the answer. When will it not be possible to do this? For 1, 1. Hmm? 0, 0, 0. After adding 2, the length will still be odd. So if the length of the string is odd, the answer will always be minus 1. But if the length of the string is even, we can make it good. And I just have to print them. And I have to do this using two pointers, one from the right and one other from the left. But how will I keep track of where to and where not to add a zero one in the algorithm? Hmm, again, 0 0 1 1 1 0. Let's say I have a pointer I and a pointer j. I goes from hmm, huh, I goes from 0 to n minus 1. J goes from n minus 1 to 0. So if I is equals to j, where I is equals to a of j, then if both of them are 1, if a of I equals to 0, then we add 0 1 after j and shift j. But how to write this? Oh, 0 1 2 3 4 5. No, I think the numbering starts from 1. 1 2 3 4 5 6. Hmm. 1 2 3 4 5 6. 6 and 1. So we can see that A of I is equals to A of J and A of Y is equals to 0. So we add 0 1 after the 6. So now the original array will be 1 1 1 0 and 0 1. Now J is equals to J plus 1. I is equals J minus 1. I is equals to I plus 1. And hmm, 1 2 3 4 5 6 7. J equals to J minus 1. The question was like 1 1 0 0 0 1. They are not equal. So I will add a 0 1 before this. 0 1 1 1 0 0 0 1. Good, 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 and good. So if I encounter 0 and 1, sorry, if I counter 1, I will have to make two integers to for the displacement of I and j for the answer, that is, if I encounter 1, the cutoff of I will increase by 2 and cutoff of j will also increase by 2. But if I encounter 0, only the cutoff of j will increase by 2. And in printing the answer, I will print j plus cutoff of j or I plus cutoff of I. This should work. CP LL T C in T while T minus minus LLN C in N हाँ L string S C in S. If n percentage by 2 is equals to 0. What about a string of length 1? Nah, it's not equals to 0. See out. Let us play with bool flag equals true. Flag equals false. Else. If n percentage by 2 is equals to 0 for LLI equals to 1, 0. LLJ equals to n minus 1. I is less than n. J is greater than or equals to 0. I plus plus j minus minus. If s of I is equals to s of j, if s of I equals 1, ln uh, c of left and ln c of right, c of right plus plus c of left plus plus. Else if s of I is equals to 0, c of r plus plus, but c of l remains the same. And after doing this, I can just make a vector VLL V. V dot push back VL plus I. हाँ, V dot push back VL CR plus J. Or is it? Nah, this should work. C out V dot psi and I equals to V dot is less than V dot psi I plus plus. C out V of I. हाँ, C out and L. Here we go with this. हाँ, हाँ. I think this is okay. It should not cause a problem. And like comma j. Hmm. Hmm? Oh, comma. It was a thing causing a problem. 6354. Specify is equals to S of j. The out S of I, S of j, and L. You can go out for a second. No. Ah. What's the L? S of I. Ah. Oh, 00. Oh, how about I minus minus j plus plus. Huh? 001111. No. 00. What does my code do? 001110. If these are equal, yeah, they are equal. And now we will go here. We dot push back tr plus j. Tr is 1 and j 0, 1, 2, 3, 4, 5. So this equals to 6. Tr plus plus. Because I will add a 0, 1 here. Hmm. And then 0, 1 here. And a 0, 1, 1, 1. How do I tell that there is now one more 0 instead of the one I already had? An extra 0 past that. I can't just do plus equals 2. I can't. Oh, how about s of I, s of j plus 2. is equals 0 plus equals to, and here C plus C plus J plus equals to minus equals to f of I minus 2 is equal to 0 or 1. 3, 4, 5, 6. Mhm. I know what I need to do, I just don't know how. I know what I need to do, but I just don't know how. That is 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 0. A plus plus. Hmm. Hmm. That's good because remove this. If S of I is not equal to S of J, I plus plus J minus minus, else if S of I equals 1, so I won't change I, but I will do J minus minus. And here I won't change I. I won't change J, but I will do I plus plus. This is the way. Let's just think how. 0, 0, 1, 1, 1, 0. No, 0, 1, 1, 1, 0. Both the zeros are equal. S of I is equals to 0. Why do I did this? Hmm. CR plus plus and I plus plus. 5, 6, 7, 4, 5, 6. There is no need for that. 67456. Right. Uh, if not flat. C out minus 1 and L. Minus 1 minus 1. 2. Uh, if flat. Level is 0, 1. Hmm. Hmm. Yes, I'm listening. Uh, I guess 7 is working correctly. Let's see this place. If I encounter 1, I will not do I plus plus, but I will do j minus minus. 67456. But the answer would be just 2, 6, and 7. Why is there a 4, 5, 6? There is no need for that. Uh, mm, I equals to 0, j equals n minus 1. I is less than n, j is greater than equals to 0. If s of I is not equals to s of j, I plus plus j minus minus else. If s of I equals to 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 0, 1, 0, 1, the zeroth position. Hmm? After zeroth position, position where you want to insert 0, 1. If x of I is equals to 0, you insert 0, 1 at the beginning of S. So once you insert the beginning, I always will have 1. Hmm. The 1, 1, 1, 0, 0. See how S of C and then 0 and 0. So it's working correctly. That's why it's working. Oh, LLI equals to 0, LLJ equals to 0, while J minus I is not equals to 1. Hmm. While J is not equals to I. G minus I is greater than 1. We have J, I, and L. Hmm. Oh, minus 1. Huh. So I should have just used 2, 1, 10, 4, 5. Hmm. And don't ask me, I will just try to avoid solve. We'll copy this entire thing. Paste it here. Return 0. Close 3 out. Minus 1. And return 0. And return this return. Hmm. Why? Yeah, 10 percentage by 2 and mm, removing this and we have 10 percentage by 2 and so see for two test case and even third test case gives -1 using 1111 or 0000 is an invalid answer. Which are equal. I will do 011111. It's infinite. 000001. Mm. It's equals to 0. X less than n. I plus x of 5 equals to 1 and L flag equals 0 equals 0 and f2 equals 1 break 0 if f2 is equals to still 0. See out now. Dot -1 and else. Let me just make this system. Or someone in the chat. Hi. Stay Lariel, how are you? Could it be you just left? Because it's a sad thing. And thank you for the sub now. Well, just following me in general. I guess you left. So bye. What's it? You speak to this guy. Hi, how are you? I told you can explain to people. Let's just end this here as I have to go to the gym. Today I will do chest and triceps. So let's meet again after doing that. So bye in the meantime.